Why have Earth days been randomly changing in length? We all know that a single Earth day technically contains 86,400 seconds. This has been since the year 1000, when Muslim scholars subdivided the mean solar day into 24 hours and the corresponding minutes and seconds. But as soon as our instruments improved, we discovered the Earth's rotation period varied irregularly, at something like a fraction of a second each year. We will see how that is possible later in this video, but for now, imagine if our clocks were off by just a few seconds. Over time, those seconds can add up and cause significant discrepancies in timekeeping. That's why scientists needed to define the concept of a leap second to ensure that our clocks are as precise as possible. To put it into perspective, a leap second is like a leap year, but on a much smaller scale. A leap year is added every 4 years to account for the fact that the Earth's orbit around the Sun isn't exactly 365 days long. So just like how we add an extra day in February every 4 years, we also add an extra second to our clocks as needed to account for the minute changes in the Earth's rotation. Some people might think that being born on a leap year is unlucky, since they only get to celebrate their actual birthday once every 4 years. But let's be honest, they get to age 4 times slower than the rest of us, so maybe it's not so bad after all. But all jokes aside, the gradual slowdown of the Earth's rotation is a real phenomenon that has important implications for our planet's climate, geography, and even timekeeping. So let's dive into the science behind it all and explore what's causing our planet to change its rotation velocity over time. Let's go. Leap second. The definition of a leap second is crucial for accurate timekeeping on Earth, as it helps to align atomic time with the Earth's rotation. All of this is really important because, hey, you don't want to be 1 second late to your job interview at NASA. The Earth's rotation speed changes irregularly and randomly, and this unpredictability is why leap seconds are announced only 6 months in advance. Physicists Stevenson and Morrison developed a mathematical model that shows a steady increase in the mean solar day by 1.70 milliseconds per century, while the rate of lengthening of the mean solar day has been about 1.4 milliseconds per century over the last few centuries, which is the sum of the periodic component and the overall rate. One thing is clear from the model: the Earth is slowing down. But why? How is that even possible? The primary reason for this slowing down of the Earth's rotation is tidal friction, which would lengthen the day by 2.3 milliseconds per century. Other contributing factors are the Earth's crust movement relative to its core, changes in mantle convection, and any other events or processes that cause a significant redistribution of mass. These processes alter the Earth's movement of inertia, which affects the rate of rotation due to the conservation of angular momentum. Some redistributions increase the Earth's rotational speed, shorten the solar day, and oppose tidal friction. How the Moon slows down the Earth? Let's focus on tidal friction. What is it, and how does it exactly slow down the Earth by 2.3 milliseconds per century? Tidal friction occurs when there is an interaction between two objects, such as the Earth and the Moon. The gravitational forces from the Moon create tides in the oceans, causing them to rise and fall twice a day. As the tides move across the Earth's surface, they create friction which generates heat. This heat causes the Earth's rotation to slow down gradually over time. As the tides move across the Earth's surface, they rub against the land and create heat. This heat then causes the Earth's rotation to slow down. It can't be hard to imagine how tidal friction does it, but let me simplify it down to a very familiar example. If you've ever turned a bicycle upside down and spun one of its wheels, you could slow down how fast the tire spins by putting your hand on the tire. Tidal friction is like a brake applied to the Earth's spin, and it lengthens our days as a result. Tidal friction is not magic, but rather a natural process that is governed by the laws of physics. It's important to note that the amount of friction generated by the tides depends on a variety of factors, such as the size and distance of the Moon, and the shape of the Earth. This phenomenon is not only important for understanding the Earth's rotation, but also for the presence of life on our planet. Without the tides created by the moon, the oceans on Earth would be stagnant, and life as we know it might not have evolved. The tides provide essential nutrients and oxygen to marine life and help regulate the Earth's climate. The Earth-Moon system is not the only one generating tidal friction. Other famous examples are the moons and planets in our solar system. For example, we know the moons of Jupiter and Saturn experience strong tidal friction, which causes them to have active volcanoes and geysers. Hey, if you're still here, it's because you're enjoying the video. If you want to be updated about all the new videos, consider subscribing to our channel. How does the ice change the Earth's rotation? This is not the end. Sometimes the Earth likes to speed up its rotation too. For instance, let me tell you what happened 20,000 years ago with the end of the Ice Age. The melting of ice from glaciers and polar ice caps led to a redistribution of mass on the Earth's surface, which affected the planet's rotation. As the ice melted, the water was flowing towards the oceans, causing a shift in the Earth's mass distribution, thus changing the movement of inertia of the Earth. This change in moment of inertia affected the overall rotation of our planet, causing it to speed up. According to a study published in the journal Science Advances, the loss of ice mass in Greenland and Antarctica has caused an increase in the Earth's rotational speed. The researchers found that the melting of ice from these regions has led to a shift in the position of the Earth's axis, causing it to tilt more towards the east. This shift has increased the Earth's rotational speed, shortening the length of a day by about 1.8 milliseconds over the last century. What's really interesting is that we as humans can change the rotation rate of the Earth. And that's not necessarily a good way of doing that. Think about the melting of ice due to climate change. It can have a similar effect on the Earth's rotation, although the impact will be relatively small. A study published in the journal Science Advances found that the melting of glaciers and ice caps due to climate change could cause the Earth's rotation to speed up by about 12 microseconds per year. While this is a small effect, it could add up over time and have a significant impact on the length of a day in the future. Is there anything else you want to know about climate change and its effects on Earth's physical parameters? Let us know in the comments below. How do earthquakes influence the rotation of Earth? Earthquakes can also influence the duration of the day on Earth, but in a different way. When an earthquake occurs, it can cause a redistribution of mass on the Earth's surface. This change in mass distribution affects the Earth's movement of inertia, which can either speed up or slow down the rotation of the Earth. For example, the magnitude 9.0 earthquake that struck Japan in 2011 caused enough mass redistribution to shorten the length of a day by about 1.8 microseconds, or about 1.8 millionths of a second. This is because the earthquake shifted a significant amount of mass from the Earth's equator to its poles, which made the Earth spin slightly faster. However, not all earthquakes have this effect. The size, location, and type of earthquake all play a role in how much mass is redistributed and how it affects the Earth's rotation. Scientists are still studying this phenomenon to better understand how earthquakes can influence the rotation of our planet. The shortest day on Earth. At this point, you might have one big question left. If the duration of days on Earth changes randomly, what's the shortest day ever recorded? Well, this is indeed a really good question, and the answer is probably it happened on June 29, 2022. The duration of that day was 1.6 milliseconds under 24 hours, making it the shortest day we know of in history. This really points out something crucial. The Earth's changing in rotation depends on a variety of factors, and the random combination of some of them can have different outcomes on the length of a day. It could make it at times shorter, at times longer. Will the shorter day add up over a long period of time? We might need to use a negative leap second. Negative leap second. In fact, it is vital to note that leap seconds are not indicators of a slowing of the Earth's rotation rate. Instead, they are indicators of the accumulated difference between atomic time and time measured by Earth's rotation. The average length of a day in 1972 was approximately 86,400.003 seconds, while in 2016, it was approximately 86,400.001 seconds, indicating an overall increase in Earth's rotation rate over that time period. Positive leap seconds were added during that time because the annual average length of the day remained greater than 86,400 International System seconds, not because of any slowing of the Earth's rotation rate. Recent reports show that Earth was spinning faster in 2020 and experienced the 28 shortest days since 1960, each lasting less than 86,399.999 seconds. That's what led engineers worldwide to discuss a negative leap second and other possible timekeeping measures that could eliminate leap seconds. This, in turn, highlights the importance of accurately defining a leap second to ensure the precision of timekeeping on Earth. That's all for this video. What do you think about the change in the Earth's rotation? Let us know in the comments below. We'll see you next time on the channel.